Hi guys, this is lesson 4 in unit 11. Today we're going to talk about box plot, or another name for it, box and whiskers. So what is a box plot? A box plot is a graphical representation of a data set as a box in which the data ordered and divided into 4 intervals or quartiles. Each quartile contains approximately 25% of the data. And the first quartile is also called the 25th percentile, lower quartile. 25% of the data lies below the first quartile. That's why it's called the first quartile or 25th percentile. The median, the second quartile or the 50th percentile, is where 50% of the data lies below the second quartile. The third quartile, or the 75th percentile, or it's also called the upper quartile, contains 75% of the data. Let's take a look at this example. We need to find the 5 statistical data summary of the box plot that we have here. This is an example of a box plot, and we have 5 main points that we need to know just looking at this or examining this box plot. The first point that we can get from this box plot is the maximum, which is 100. So the maximum is the last value that you will see on the box plot, and then we have the minimum, which is 65, which is the first value you will see in the box plot. Now, the first quartile is 70, which is the value after the minimum. The median or second quartile is 80, and which is the value in the middle of the box. Sometimes it's shifted to the right and left. That's in the median. And the third quartile, which is 90. Now, looking at this box plot, I know that most of my data are here in the middle. That means if I want to describe the shape of the data, I'm going to have a distribution that looks like this, which means that the median here is in the middle at the top of the mountain. That means that I have a symmetrical distribution. We're going to talk also about the interquartile range. An interquartile range is a measure of statistical dispersion or the spread. So before we talked about the range as a measurement or a measure of the spread, we talked about standard deviation. Today we're going to talk about the interquartile range, which also we give a symbol as IQR. The interquartile range is equal to the difference between the third quartile or the upper quartile and the first quartile. It is also called the mid-spread or the middle 50. And we can get that value of the interquartile range by subtracting the first quartile from the third quartile. Let's take a look at this example where we have the scores of 10 students on their math quiz. We have 60, 66, 66, 68, 72, 72, 73, 74, 75, and 80. We're trying to find, we're trying to construct a box plot for this data set. And to be able to do that, we have to find the 5 statistical data summary for this data set first to be able to construct the dot plot. So using the calculator, just like I showed you last time in my previous video, we'll find out that the minimum in this case is equal to 60, which is the lowest grade or score. The maximum is equal to 80, which is the highest score, the calculator can calculate for us the first quartile, or Q1, and in this case you'll find out that Q1 is 66 actually, and then the second quartile, or the median, is equal to 72, and the third quartile is equal to 74. And these are the 5 main points that we need to be able to construct a box plot. So I'm going to put my numbers on the number line at the bottom here, but I want to put these numbers in a way that can help me construct an accurate box plot. So I'm going to start by 60, and then I'm going to skip 2. So I'm going to add 2 each time. 64, 66, 68, 70, 72, 74, 76, 78, and 80. Okay, so now I need to construct the box plot above the number line, not on the number line, but above the number line. I'm going to make my 5 marks for the 5 main points, the minimum, the maximum for the whiskers, 66 for the first quartile, 72 for the medium value, and 74 for the third quartile. And now my box starts with the first quartile and ends with the third quartile, and then the whiskers extend to the minimum and the maximum from the first and third quartile. So this is the box plot that I have here for this data set that shows the 5 main points. Now if we look at this dot plot, this box plot, we'll see that the median is not in the middle of the box. And if I want to describe this, the shape of this distribution, I can see that my data is going to be concentrated here where the median is, and then go down there. So looking at this shape of this data set, I can see that this distribution is skewed left, because most of the data are not in the middle, they're shifted, and the tail of the distribution is to the left.